Hi, this is our review for our Chapter 1 test. First one wants us to graph this piecewise function. So for x less than 0, it's going to be this line that has a y-intercept of 2 and a slope of 1, up 1 over 1. It would kind of go like that, but we're going to come backwards with it. And so it looks something like this. The other one is this, again, a parabola that's turned on its side. If I put 0 in, I get the square root of 4, which is 2, so it will fill this in. If I put 1 in, I get square root of 5 and square root of 6, so I should have some kind of a curve going this way like that. Okay, so that's what that looks like. Then they want us to evaluate based off of this. So h is 0, we're going for the spot where it's equal to 0. So if I put 0 in, I get square root of 4, which is 2. Negative 4, I'm going to the spot where it's less than 0, so negative 4 plus 2 is negative 2. 12, that's where it's greater than 0, so if I put that in, I get square root of 16, which is 4. The limit as h approaches 0, so now I got to think about it as it comes towards 0 from the left and the right. Both cases, it's approaching that value of 2, so since there's agreement, I have a limit there. And as I approach 5, I'm only looking at the top one, so that'd be square root of 9, which is 3. There's no break or jump there, so it's going to be just what the function equals. So hopefully you have those values there. C says, is the function continuous at 0? Justify your answer. Well, we definitely have a limit as x approaches 0, okay? And we have a function value at 0, and those two are equal. So you'd want to list that out in 3 separate things. We have a limit, we have a function value, and they're equal to each other, so the answer is yes. All right. Determine these. We're supposed to not use a calculator for A through D, so we want to try to use some of our steps here. Again, next chapter we're going to show you another method that might help you. But if I break that down to x plus 3, x minus 3, I can pull a negative 1 out of the bottom, and I'll have x minus 3 down there too. The x minus 3's cancel, and so now I have x plus 3 over negative 1. I want to take the limit as x approaches negative 3 to that. If I were to put that in there, I would get 0 over negative 1, which is 0. All right. If I go over here to this one, I can let the x's cancel. I get the limit of 8/3 as x approaches 0. And since it's a constant 8/3, it's just going to be 8/3. That'd be our limit there. Okay. This one here, if I factor this x plus 2, x minus 2, I can let the x minus 2's cancel. I get 1 over x plus 2. So now if I take the limit as x approaches 2 on this, I'm going to get 1 over 2 plus 2, which is 4. And then on D, if I were to put 3 in, I'm going to get 0 over 0. So I want to multiply top and bottom by the conjugate. And again, these are things that the AP won't make you do. We're just kind of seeing if you can right now, and nothing to get too panicked about as far as our test goes. But negative 2 times 2 is negative 4. The outside inside would cancel. That's why we did this conjugate idea. And then the bottom, I'm going to have this right here. All right, so on top, x plus 1 minus 4 is x minus 3. That's going to cancel there. So I'm going to get 1 over the square root of x plus 1 plus 2. I'm going to take the limit as x approaches 3 on that. And that's going to give me 1 over square root of 4, which is 2. 2 plus 2 gives me 4 for that. Okay. On this one here, what you'd want to do is graph this. And in looking at the graph, you're going to see it approach something at 0. And so we'll go ahead and show you that right now. So if I go to y equal, and I type in, I'm going to go alpha trace sine x over 1 minus cosine x. All right, and again, I want to see what's going on as I get closer and closer to 0. So here's what that graph looks like. And it looks like it's probably just hugging the x-axis. We're not seeing a whole lot here. So if I change my window, let's say I go negative 1 to 1, so I get a little closer shot at things here. And I'm wondering now if I'm actually in radian, I'm in degree mode, yeah. Let me change to radian mode. Always a good idea to be in radian mode. There we go. Now we're seeing a little bit more. Okay? And you can see that what's going on here is we have a little bit of almost a vertical asymptote there. If I were to go back to my regular window, probably see it a little bit better here. And we can see that we've got an asymptote going at that 0 mark. So the limit, since it's from the left and the right are not agreeing, we would say this limit does not exist. Okay? On the other one here, if we were to try graphing that one, let me delete that. Let me go e to the x on that. All right, and then down below, if we delete that and just put in an x. Oh, sorry, and I need a -1 up there. All right, so this is what we get on that one. If I hit zoom 6 there. Okay, again, I'm trying to see what's going on at 0. And it sure does look, as I come from the left and from the right, we're approaching this value of 1. So we would say that that one is 1. Now, a little bit later, next chapter, in the chapter after that, we're going to be able to prove that this one doesn't exist, and we're going to be able to prove that that's 1 using derivatives. But for right now, that's what we get right there. All right, so that's page 1 of our review.